Hello and welcome to Asynchronous and Unreliable, a new weekly podcast where we discuss the most interesting ideas in tech. I'm your host, Anne Currie, co-author of Building Green Software, The Cloud Native Attitude, and author of the science fiction Panopticon series. I also offer consultancy, training, and workshops at strategically.green. And as for my guest today, to celebrate Earth Day, and and arguably it's still Earth Day, we will discuss whether it is really still Earth Day, because we're recording this on Thursday, not Wednesday, but it's Earth Day in Hawaii. So arguably it's still Earth Day. We have sustainability and green software expert, Niki, who I first met as one of the many technical contributors to Building Green Software. So, Niki, do you want to introduce yourself?
Sure. Hi, everyone. And thank you, Anne, for bringing me on the podcast. I'm so excited to be here, along with the really great cohort that you have put together. I'm Niki Manoledaki. I'm a senior software engineer at Grafana Labs on the platform engineering team. And I'm a longtime open source contributor. I lead a few different projects in the open source ecosystem, particularly in the Cloud Native Computing Foundation. For example, Kepler, an energy monitoring tool, and also previously the technical advisory group for environmental sustainability has been a big focus of mine. I'm so excited to be here to talk about cloud sustainability, and it is still Earth Day in Hawaii, so it's Earth Day somewhere, and I'm mentally in Hawaii right now.
Yeah, we all are, I think. Yeah, I've never been to Hawaii actually. It sounds fantastic.
I mean, I was researching the meaning of Earth Day, and definitely Hawaii is a beautiful place to think of Earth Day happening. It's beautiful, beautiful nature for sure.
One day we'll all go to
One day
Hawaii.
we'll go to Hawaii.
Yes. So, yeah, it's yeah, so it's very appropriate that it's a whole Hawaii themed. We didn't have anything, you know, te- uh, culturally insensitive or whatever. Fortunately, we couldn't kind of like grab our leis or whatever, or that was we were spared that. You've all been spared that totally culturally inappropriate, probably experience of seeing us attempt to pretend to be in Hawaii. But today this is an Earth Day talk. We will be talking about green things, and the one of the interesting things. So you were a major contributor to the operational chapter of Building Green Software, because ops are your area. So I'm very interested, and you do a lot of interesting work around effectively operational efficiency and aligning the operation of your systems with renewable power availability. And you work on that from multiple angles, multiple really interesting angles. One is, well, I'll just say one is your involvement in Kepler. The other is your involvement in um, uh, monitoring and tracking sustainability for systems through your job. So it would be great to talk about both those things today. So I don't know which one you want to talk about
Mhm.
first. They will both be good.
My day to day is with cost monitoring, and that's something maybe people don't know about me. My day to day is monitoring the cost of resources at a lot with a lot of granularity. So what I generally care about is what we talked about in building green software is the trifecta of cloud sustainability, which I describe as energy, carbon, and cost. On the cost side of things, I know it's a complicated topic when it comes to tying cost and carbon, energy, or efficiency in general. But what I do in my day to day is creating cost metrics that can be used by engineers by tying pricing and utilization metrics. So that's where it really connects with operational efficiency, because we multiply we multiply pricing with utilization. So, for
Mm.
example, CPU utilization, or load balancer utilization, or virtual machine utilization for EC2 instances, different kind of utilization metrics that we usually get depending on whether it's running on Kubernetes or if it's not running on Kubernetes. We'll use different calculations. And we do all this through Prometheus recording rules. So we have a set of cost metrics through Prometheus queries that we build and maintain and extend, and we add granularity to, and we aggregate them in different ways. We add team level attribution to them as well. We can calculate unit costs. We can use this unit cost during the release process to show that the unit cost has stayed the same release by release, which is really
Mm.
unit economics is I was reading in the Finops book, the Cloud Finops book by O'Reilly. Unit economics is the nirvana of Finops, and that's where you want to be. And also, then you can use this unit cost to tie production costs to SKUs, which are stock keeping units. And that's where my team is right now. And it's a very exciting place to be. Um, Energy comes into it if you look at cost per watt, which is not something we've achieved yet, at least in my team, but I'm very interested in going in that direction, especially when it comes to AI. I've been listening to a lot of discussions around the limit of AI scaling, and obviously one of the biggest limiting factors of AI is energy
Yeah,
consumption.
absolutely. Yeah.
So a lot of companies are trying to tie operational efficiency and cost per watt, which I think is where we're heading.
Yeah, so that's very interesting. I imagine that's really interesting. There's loads in there, and now we're going to unpack that and slightly talk about it. And I'm going to roll all the way back for our listeners and viewers to the very beginning of this, which is why FinOps. So your involvement. One of the things that that you suggested that we put in building in software was that the algorithm, the very simple algorithm, which I like a lot, which is GreenOps, and this was a CNCF when you were still very heavily involved with CNCF at the time. The CNCF statement of GreenOps, definition of GreenOps as FinOps plus GitOps, which is effectively GreenOps is automated FinOps. And the reason for saying, well, GreenOps is all about cost is because they're both really about the same thing. So operational efficiency and being green is about cutting the amount of resources you're using to do the job. So not cutting the amount of job you're doing, cutting the amount of resources you are doing per unit of delivery, or whatever that unit of delivery is, the SKU or whatever. Order or visits or whatever the unit of delivery is. So you want to cut the amount of resources, and the resources that you're trying to cut are generally the machines, the number of machines you're using, the amount of hardware that you're using, and the amount of electricity that you're using. Those are the two key resources, and they both have a cost associated with them. Obviously, the cost of buying the hardware, replacing, maintaining the hardware, housing the hardware, which is more costly and difficult than it often appears. And then electricity is the cost of electricity. Now, as you say, that one of the difficulties of one of the things that you are sounds like you are trying to achieve, and I totally and wholeheartedly applaud this, is making it quite like for like. So you're kind of saying, well, the only way you can move forward with improving things is if you have something where you can say, well, this is better this week than last week. And to a certain extent, you have to isolate some of the actual rightness, the moment by moment changes in the information that would just hide the underlying issue from you. So that it's why often money is a better metric for early days in improving your operational efficiency than, for example, carbon, because carbon mix or carbon intensity of the grid varies moment by moment. So it's very hard for you to tell whether a change that you made your system less operationally efficient by meaning you use twice as much electricity and twice as much hardware, which is often a decision that is under your control as the ops team or the coding team. Or it was just sunny. It was just less sunny than expected this week, and therefore your carbon emissions have gone up. So it's really all about operational monitoring. Is really all about giving you actionable information, not true information that is not actionable. So it's prioritizing actionability over moment by moment correctness. Is that correct? Is that right?
Absolutely. And absolutely. And what we've done is we've decentralized, as a platform engineering team, we've decentralized the optimization of resources so that each engineering team can can perform and implement these optimizations because they are the domain expert. They are the specialist. So Grafana Labs, as you know, maybe has there's logs, there's metrics, there are traces. I'm a platform engineer. I'm a specialist in Kubernetes. I might not have much in my toolkit beyond, deploying autoscalers like Carpenter and the Vertical Pod Autoscaler. And we do that very well. We do that very, very well. We've achieved a really good utilization efficiency metrics as a platform team using Carpenter, and we maintain the Vertical Pod Autoscaler so that there's right sizing
Yeah.
available for engineering teams.
So I'm going to interrupt you there because you've introduced a lot of concepts
Mhm.
which I know all about because we me and my co-authors had to well, we knew about them already, but we did a lot more investigation writing about them as for writing the book. And so you've introduced a couple of concepts there that are utterly key to operational efficiency. So using fewer machines to produce the same results. I would say probably the most fundamental one, which all the others kind of serve to improve, is utilization, machine utilization. And what that means is if you're running if you've got your system set up, and this is very, very common. I think a couple of years back it was Gartner came up. So the average enterprise has a machine utilization of 10 to 15% in their data centers. That's not surprising. That's and if you look at somebody who's doing things really well, like Google, who have excellent machine utilization, they have more like 80, maybe even 90%. They have the 80 to 90% range of utilization. That means that for doing what should be a similar job, Google require maybe 7 or 8 times fewer, like 10x effectively fewer machines. They use 10x fewer resources, an order of magnitude fewer resources to deliver the same effect because they're really good at machine utilization. And that's that there's no debate over that. If you just have fewer machines and as a result you're using less electricity, because a partially utilized machine uses more or less the same, a lot of the electricity of a fully utilized machine. So there's no, it's a no-brainer to reduce the number of machines that you've got and increase the utilization. So utilization is the key thing in operational efficiency. To increase your utilization decreases your resource usage. And a couple of the techniques that are used to do that are autoscaling and also so you mentioned Carpenter of scheduling, clever schedulers. So why don't you tell us a little bit about how autoscalers do it, and then we'll talk a little bit about how clever
Hmm.
schedulers do it.
So there's a couple of different concepts that we can use with autoscaling in Kubernetes. One of them is bin packing, and the other one is right sizing. So bin packing is exactly what you're describing, where we try to orchestrate as many pods to land on the same node so that we can reach a higher percentage of utilization on that node, ranging from 70 to 90%. 80% is probably your sweet spot. Anything above that starts to actually be a regression in terms of performance. We've seen that anything closer to 90% can actually increase latency for scheduling things, or pods that are burstable cannot scale up. And I also have seen some academic research around, the energy efficiency on machines starts to degrade at these really high levels. So probably, I think the target would be 70 to 90, ideally 80%.
So
So
I'm
that's
gonna
bin packing.
so I'm going to zoom in a little bit on that one as well, because that's oddly enough the subject of another book I wrote separately before the cloud native before building green software, called The Cloud Native Attitude, which is about kind of what are the modern techniques that have led to the cloud and led to the ability for the cloud to make as much money for cloud providers as it does, and for, if you use it right, for it can be very good. But it's all down to whether are you cloud native or are you not cloud native. But all of this bin packing is about, okay, well, look, I've got, rather than just having one application per server, which is used to be the way that things ran, and that leads to your 10% utilization or even less. If you wrap each application in something, in some kind of encapsulating layer, now that might be a virtual machine. It totally encapsulates your application, but it's more lightweight if it's a container, and it's quicker to move it around, and it's quicker to start and stop it if it's a container. So you need a wrapping to wrap up your application. So virtual machine or container, and then you can say, well, hang on a minute, let's bin pack my applications onto the effectively at the lowest level onto the physical servers that I've got, like Kelsey Hightower always used to do an excellent visual representation of this when he would play Tetris live on screen. He said it's like playing Tetris live with your operational, with all the applications that you want to run across your entire estate. But and his point there was, you can't do it manually. You can't have your engineers sitting there building. If it required people to be playing Tetris live, then you wouldn't be doing it on your systems. But automation through things like Kubernetes, of schedulers like Carpenter, allow you to effectively do that, playing Tetris and bin packing applications onto your physical servers in an automated way all the time, in a way that humans could never possibly do. All of this auto-scaling and bin packing and the efficiency levels that you're talking about of 80% are only achievable because of programmatic control of data centers. So, which at the beginning of my career certainly was not a thing, even until, for most enterprises, it's still not a thing, but it is a thing.
Yeah, that should be a must. This kind of really smart bin packing using an orchestrator like Kubernetes is such a lifesaver when it comes to computing at scale. But then the maturity model continues. The way I see it, after you've bin packed as much as you can and Carpenter is doing its thing, the next thing that you can implement is right sizing. And then I'll get to unit economics, but right sizing is when, well, okay, let's look at the pod's anatomy. It's going to
So,
request an amount.
define a pod for us.
A
I
pod
have a
is
wide range of listeners.
it's a container, which is just an application, a workload. It's the unit. it's the smallest unit of components in Kubernetes. So let's say you wrap up your application in a container. Maybe you use Docker. You then have a deployment, a manifest for your application, and then you have maybe 3 replicas of your application running in the Kubernetes cluster. So at that point, what you can do is you can set the resource in terms of CPU and memory that your application will request when it's being scheduled onto a node. So it will request memory and CPU utilization. You can set a limit, which is very important to set a limit for how much your pod is going to request. And but you might not always get it right. You might over provision CPU and memory for your application, for your pod. So at that point, what can help is something called the Vertical Pod Autoscaler, which is another Kubernetes tool that can help with right sizing. So right sizing with VPA is when you set a really high upper limit, but then below that, the VPA the VPA algorithm will adapt the memory and CPU that your pod is requesting. So it might lower it, it might increase it, and that's another smart tool that you can use, another scheduler that you can use to optimize resources at that small unit that is your pod.
Now, so that's very interesting. And it's interesting because right sizing used to just be kind of like, well, if you're talking about a physical machine or a VM, I would have said a VM was you get a VM and you say, oh well, hang on a minute, you over provision the VM, you get a bigger size than you need to, you buy a bigger machine than you need to, and then you say, well, actually, that wasn't really what I wanted to do. And if you're on prem, it's more difficult then because you bought the machine and you go, well, I'm using it. In the cloud, one of the whole points of the cloud is that you can right size. You can say, actually, that VM was a bit bigger than I need. Can I shrink it? And a good ops team will be doing that all the time. You always over provision to start with, and then you right size it because you don't really know when you first deploy something. It's very hard to know how much resource it's going to need. And so you over provision because that's the sensible thing to do. Because if you over provision, then it costs you money. If you under provision, it falls over. So you always err on the side of caution and over provision. And then at some point later, you manually go back through usually and right size. In the old days, you'd have gone manually through and said that VM is a bit oversized. I'll move to a small one. And in fact, that never really happened because physical processes like that, where you go through and ops teams are busy, and they don't really need to. It just costs money, so they don't go through and right size. So one of the big things that we've all been trying to work on is how do you make right sizing happen automatically, auto scale, so that people you're not relying on people going, oh, do you know what? I've got a load of spare time at the moment, so I'm going to go back and do a right sizing review, a manual right sizing review of my entire system, which, let's face it, never happens. It does sometimes happen because I have come across companies that do something called thriftathons. Where rather than doing a hackathon, they all go, actually, let's see if we can make this system greener and cheaper to run. We'll do a thriftathon. And at that point, we go through and right size everything and make a bit of and have a beer or whatever. But don't have a beer while you're right sizing your systems. But never have a beer while you're making operational changes to your production infrastructure. But generally speaking, right sizing never happens. So you're talking about automatic right sizing. Now, there are two, but I'm also going to zoom in because you're talking about quite a clever, a second and a meta level of right sizing your systems. You can use things like auto scaling that people are often quite familiar with on VMs. And an autoscaler in a VM will kind of like fire up more VMs. It won't actually, generally it's about firing up more VMs and scaling horizontally rather than vertically, making the VM bigger, because that's a bit complicated. But autoscaling generally on clouds is about, okay, we're running out of resources. I'm going to create some more. I'm going to scale vertically, create more copies of this application, and run up my capacity that way. That's autoscaling. And we talk about that in Holly Cummins talks about that in Building Green Software. But that is a kind of meta VM level autoscaling that everybody's quite used to. But this is a cleverer kind of, this is a zoom in autoscaler. This is about someone saying, well, rather than doing we're very familiar with the concept of autoscaling at the VM level by firing up more VMs. But what if we were to start looking at within at the container level rather than the VM level? I said a bit like we're playing Tetris, and it turns out that everybody's just got bigger squares and shapes on the Tetris than they really needed to, and you fitted them all, and and they fitted at the time, but actually it was only because people were trying to make them bigger than they needed to be. Is there a way that we've already got these out there, we've got them running? Is there a way we can just say, let's make all of those smaller and fit in more onto these machines live as you go? And again, that's something that realistically could never have been done by human hand. That's playing live Tetris squared. You're playing live Tetris, except that the size of the shapes as they're falling are changing. There's just absolutely no way that could have ever been done by an operational team manually. Even Kelsey Hightower could not do that live, say on stage during a talk. Is that really? But you could of course do it programmatically, and that is what Carpenter is about. It's about saying that was always bigger than it needed to be. Let's make it smaller, and then let's replay that whole Tetris screen to fit more stuff onto the machine because actually it was bigger than it needed to be. So it's a kind of meta level of over provisioning. Is that? Do I have that right?
Yes, and so a lot of this can be automated, and we've seen also some use cases where the vertical pod autoscaler, it can fit most workloads. It can work with most workloads. There are some exceptions that we've seen. Obviously, vertical pod autoscaler itself, but also other workloads, maybe those that have a really big spike in utilization when they start up. So startup resource utilization can be different than runtime utilization. So what we've seen is sometimes VPA, well, what VPA does, it will restart the pod when it receives the signal that it should increase its the resources for this pod. So what we've seen is these loops, these eternal out of memory loops that can happen if a pod that has been restarted to scale it up doesn't have enough memory allocated to it, so it keeps restarting, and vertical pod autoscaler fails to adjust to it and adapt its memory utilization. But Kubernetes had a really cool new feature. It was released a few months ago. Maybe it must be less than a year ago. But this in-place restart. So you avoid this problem of having an out-of-memory issue because VPA no longer requires to restart the pod in order to increase or decrease its CPU or memory utilization. It's the request or the limits for this pod. So this is a wonderful new feature that can help even some of these harder edge cases that cannot be automated with VPA. This right sizing edge cases that cannot be automated with VPA. But now we see this solution that was built in the open right? Because it's all open source, and I know I've been tracking this feature for 2 or 3 years, um, and it took a really long time to build it and release it, but it's out there, and so maybe if anyone is listening to this and has not heard of this feature, check it out because it can really even adapt to these difficult pods that were the outliers before, but not anymore.
So this kind of reminds me the I am going to have a guest later on in this podcast who really speaks to this very well. He's currently the engineering director, I think, at Skyscanner in the UK. Now, Skyscanner were one of the very, very cutting edge companies that used all of the things. So all of the early orchestration, all of the early container orchestration, and they went through. I've written multiple case studies of them over and over the many years, over the decade. And one of the things they said is, things do change all the time, and one of the really difficult things about doing this really complicated automation of your data centers is it's really complicated, and it's not just really complicated, it's very trial and error because things change all the time, and lots of stuff that gets shipped, it's still in the early days, it still has a lot of problems, so you have to be really, really comfortable with trial and error to use these early Kubernetes and scheduler features. So the Virtual Pod Autoscaler, the VPA, um, is part of Kubernetes. It's just another scheduler for
Yeah.
Kubernetes, and it's quite a sophisticated scheduler. It has been around for a long time. I really like the idea of it. It's probably not your. I wouldn't jump, but if you're new to Kubernetes, do not start there. It is definitely advanced Kubernetes, isn't it? Um,
Yeah.
you do
Doing
need to learn
journals.
the skills, and don't go.
Yeah, and I think that's the beauty of a platform engineering team working with product engineering teams, that we can hide away a lot of the complexity. Like I've contributed to VPA in code. I've gone through the code base. It's a very complicated algorithm. But the user interface of using VPA and just adding a VPA definition, which is just a YAML file for your workload. That's not that hard, but deploying VPA itself, understanding it has like 3 or 4 different components to it, understanding that can be a challenge. So I really like the contract that we've built between the platform engineering teams, maintaining these tooling and making it really easy to use. So one of my one of my past lives before I was doing unit economics, it was to make it as simple as possible to use VPA. If you're a product engineer and you're out there building Grafana or Prometheus, and you don't have the time to learn all about VPA, don't worry. I'm here for you. I'll make it so simple for you to use it. It will be so easy. The docs are there. A lot of it comes down to docs, to writing
Oh
good
yeah, a lot of it does
documentation.
come down to that. Is true. Yeah.
So I've had
So
to advocate a fair bit, but it runs itself. Eventually, it just kind of runs itself, and I moved on because there wasn't much more to do with it, to be honest.
yeah. Well, so there are a couple of things there. I'm going to pick you up slightly on you are an expert in the use of Kubernetes. You have contributed to Kepler, to VPA code, to you are hot stuff when it comes to operational efficiency. And I would say that the VPA. So what you're really signaling at this point is you feel that VPA it has been a bit, it's been hard to use, and you've got to have been part of a company that had a really, really healthy attitude to trial and error, and that's a whole company thing because stuff fails with these new, quite complex bits of software. Everybody has to be on board with the fact that You're going to massively cut your cost if you can get it to work. You're going to become you're going to be much more resilient and responsive in the long run, but you are going to have issues along the way. You're effectively saying that the virtual pod autoscaler, which I have heard is in the past is amazing but hard. I've spoken to a lot of people over the past few years who've said it's hard. It's, you have to be ridiculously good to use the VPA. And even if you're ridiculously good, there were issues with using the VPA. You're now saying it's actually more time. It's kind of closer to mainstream. So if you've used it in the past and you found it difficult, maybe now is time to take another look at it. Is that kind of what you're saying?
I think so. And I think with the in-place restart feature that landed in Kubernetes in the past few months, don't see any other edge case that VPA doesn't cover. Well, actually, that's a lie. We do have some workloads for which we don't want to use VPA, and those are some of our really large Prometheus some of our big Prometheus instances. And for that, actually, we use a cron job using Argo CD. And so we periodically will right size or Prometheus instances, the ones that my team maintains. And we built a small application for that, kind of like a replacement of VPA a little bit, but just very, 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 very simple. And we'll only right size I think it's once a week or every 2 weeks, basically because VPA right sizes very quickly and throughout the day potentially, whereas you might want a slower cadence of right sizing. So that's the exception.
So I'm going to step back and say that here you are representing, although you were here as a person who likes really green things and things like here you are representing a company that is at what I'm hearing from this is that Grafana is really very at the most sophisticated end of using a programmatic data center, a programmatic infrastructure in a data center, which is probably unsurprising because Grafana, you're drinking your own, you're eating your own dog food here. I was about to say you're drinking your own Kool-Aid, but that would be totally the wrong analogy. They're totally the wrong cliche to use in this one. You are, as a company, you're pushing people towards giving them the data to do better and to be more programmatic in their data center, to control their data center, to push down the cost of running their data center, which also pushes down the carbon emissions per unit. So unit cost, so per whatever the unit you choose, so per SKU, per order, per whatever, so that you can do like for like comparisons and say, well, it's getting better, it's getting worse in a way that's actually actionable. But what you're describing about your own internal systems are, my guess is, and this has been a while, I mean, I used to go out and interview people all the time about what they were doing for the Cloud Native Attitude book, and all its, we're on edition 3 of that at the moment. And every time I go back and talk to people about what they're doing, most people, you have to remember that most enterprises are still thinking, maybe we should run a thriftathon. They're not and manually right size things. They're so far off where you are. But it's interesting that you are running an actual application in the wild. Not an application, you're running a service in the wild using VPA. And what you're saying, Virtual Pod Autoscaler for Kubernetes, that is part of the system that you are providing as a service, is what I understand. And you are using it for pretty much everything these days. You've in the early days with these systems, it's always the edge cases. If you are a big user, you hit the edge cases and it causes you endless headaches. But we always relied on the companies like Skyscanner, for example, who were willing to push through those horrendous edge cases and learn and put the feedback in and take the pain, and it is really painful to get you to the point where a more ordinary enterprise can do it. So then that's always the case with these things, is trying to work out when it is within the scope of a and there are all kinds of enterprises. You go from the most extremely operationally sophisticated to bare competence, and all enterprises live on that
Yeah.
on that scale.
We're definitely pushing the limits of optimization at Grafana. And I think, the unit economics, the whole methodology and concept behind that is that, well, okay, what else can we do? We've deployed Carpenter, we've deployed VPA, we have covered some edge cases with some tooling, we have event-driven autoscaling in place with Keda, which is another Kubernetes ecosystem tool. We've done all these things. What else can we do? Well, okay, you know what? Let's gamify cost optimization and utilization efficiency. So this is where we are now. And efficiency doesn't end with Kubernetes. We've realized there are all these other resources that are non-Kubernetes resources that we also want to optimize. So we started with unit economics in Kubernetes, but then we expanded outside of it. What I mean by that is we did used to use OpenCost, which might be familiar to for many listeners. OpenCost is a CNCF project which is used for cost monitoring in Kubernetes, and what it does is it will query the Kubernetes API, which has information about all of the resources running on a cluster, and then it will calculate the cost of each resource. It will essentially attribute the cost of resources running in a cluster. Attribution is key here. Attribution is the name of the game. It's all about attribution. So OpenCost helps to get the cost of various resources running in a cluster. What happened was, this is very interesting. People are a little shocked when I tell them this. What happened was OpenCost didn't scale very well for us, and we do have some really, really large clusters running in some regions. And OpenCost took down the Kubernetes API because because there's so many things running in that cluster that it made so many queries to the Kube API that the Kube API was not responding well. I wasn't this happened before I joined the team, so I don't know exactly. Did it take down the Kube API? Did it stop returning? Was what I'm not sure exactly what happened to it. All I know is that it didn't scale well, and at that point we ended up building our own tool. So we haven't. It's open source. It's all open source. It's called Cloud Cost Exporter. I'm one of the maintainers of this tools. We've done some talks about it. It's just not, our plan isn't necessarily to increase adoption for it, but it solves our problem. So I'm happy to talk about it.
So you're making me laugh here, because you are absolutely demonstrating the classic behavior of a very early adopter and somebody who's pushing the boundaries of these systems. In some ways, you're illustrating my point that a lot of these systems are still for folk who are really keen on. You're the kind of people who would be talking about this at a conference. Which is, it's like you're showing what's possible, and this is all about. So it's interesting. You mentioned attribution is the name of the game here, and this isn't about blame. You're the one who cost us £100 million. This is about about delegating responsibility to the people who have the power to make the delegating information and ownership to the people who have the ability to make the changes that would actually, so rather than having someone on high say the costs, you get the information, you have the power to change your how you're doing things, the code that you're writing, the designs that you're using, and you have the information to do so, and you have the ownership. Effectively, it's a way of moving ownership towards the people who have the ability to make the changes. So that's what attribution is about. It's not about blame; it's about ownership, and
Mhm.
that's a really good thing. All of these things are interesting because they all require cultural changes within a company as well. You have to be quite culturally mature to see attribution as about ownership and not about blame. If you're in a company that still would see that is quite blame focused, then no one will want attribution because they'll go, that sounds like blame to me. And it probably would be. In some companies, it would be. You're only going to want attribution where you know that the company is all about ownership and information and continual improvement and lack of blame, not, and psychological safety, not blame. In that case, you're going to run a mile from attribution. So this is a really good example of that kind of thinking goes hand in hand with a company that can push the boundaries. If everybody is going, I want to touch attribution with the 10-foot pole because all happen will be I'll get shouted at, then you're so far off being using these systems. Almost the first thing you have to do. When I wrote when I wrote Cloud Native Attitude, I was quite interested in the companies that were doing the most on this. So Grafana would have been in Cloud Native Attitude if I'd known you 10 years ago, you'd definitely been Cloud Native Attitude. As a company that was pushing the edge. And I was looking at companies that were pushing it, were doing really well and doing amazing things and cutting their costs by 90%, that kind of thing, massively increasing their resilience. Those are the wins of this: scalability, resilience, cost savings. And we're talking 10x on this. So that's what they're all going for. And I was looking for what is the common technology that everybody was using. Is it Kubernetes? Is it, the Kepler of the day or whatever? But it was not technology. Everybody who was pushing the edge and producing amazing results, none of them were consistent in what technology they were using. They weren't even using using Kubernetes at the time. The one thing that absolutely was consistent between everybody who was doing well was CI/CD. It was an iterative trial and error mindset. Which is why we called the book Cloud Native Attitude in the end, because the technology was the attitude, not any piece of technology. It was
Mhm.
a healthy attitude, trial and error, and a safe environment in which attribution did not equal blame. Um,
Yeah.
Sounds like
I
that's
think
what you've got at Grafana, doesn't it? Really, which is
we
nice.
have a we have a really nice recipe that has led us here. I think there's a lot of factors. One of them, I love this culture, is top down, but we also have a very engineering driven culture at Grafana. We have we started with open source. It's very much focused on community and adoption and sharing things. And as soon as there's open source as a focus, as a core attribute of the engineering culture, I don't know from a sociological point of view what that means, but that openness is really key. That willingness to share and not hold on to the juicy tool that you built and that you're not going to share externally. Or
Mm.
I think there's something to it, and definitely I want to highlight that a lot of it comes down to our engineering leadership. and that the CTO, actually Tom Wilkie, he's an engineer himself, and he started, part of his for part of his career, he was a Prometheus maintainer. So he was a Kubernetes maintainer himself. I think that is a huge contributor to everything that we've talked about today. The fact that our CTO contributed to Kubernetes himself, and so that is why we operate the way we do today, and that has driven our culture towards adopting a lot of Kubernetes tooling, adapting it, contributing back to it, open sourcing all the things. So the fact that I can share all this with you is because we have such a big culture of open source, and about sharing openly, building openly, and innovating in the open. I do think that's a huge cultural aspect that helps a lot, and I think we're growing or innovation is growing so much more because of this. So I truly love open source software. I've been in this business almost 10 years, and it's just and it's been open source from day one. So I'm a huge proponent of it, and I think that yeah, that helps so much.
Yeah, so I was only going to talk for 30 minutes because I didn't want to overload people's brains. We have now talked for 50 minutes with loads of stuff, which is quite complicated. And I think, and I hadn't really, because fundamentally we all got a bit carried away here with high-end ops style. So high-end ops, which is really interesting. So if you're interested in high-end ops. Um, uh, but the reason why we all got into this was, or well, it wasn't the reason we got into it, but the reason why we really love it is because operational efficiency is green, and that's why
Mhm.
why we're here today. But so we'll both we'll both sign off on the operational efficiency is green. You do not have to be as sophisticated as Grafana, who is
Mm,
absolutely, you're not Google, but you're at that end of the scale of how sophisticated you are compared to even if you're at the very beginning of this journey. If there's one thing to take away from this, I think it's what you said at the end, which is you have to be open. You have to be willing to share. You have to put things out there and be trusting, willing to take on and try and have a play around with and accept attribution as a useful tool, not a tool of blame. Um, and iterate and just kind of go units of cost. Do I can I make this just a little bit better, just a little bit better, just a little bit better? CI/CD, rolling around feedback loops. All of
yeah,
these things are utterly key to being at that high end of operational efficiency, which Grafana is. Um, and yeah, it's more useful to have you on than somebody from Google, because Google is such a big business. I'll never be able to get someone who knows how what's going on in their entire estate. Whereas you do know what's going on in the Grafana estate, and you do know how things happen that way. So that's quite interesting. But yeah, if
yeah.
you want to take
I just love decentralizing this information, and I think it's been a core part of being a platform engineer and adopting the platform engineering mindset is that, well, my role is here to create golden paths for other engineers to adopt this important tooling. So, but I can multiply my environmental impact and my beliefs in GreenOps by sharing these best practices internally at Grafana with all the other engineers in the company, and externally um, by helping these golden paths and best practices get adopted. So in my personal growth journey, I've always tried to be a catalyst, and I've always ask myself, how can I grow and scale my impact? I think platform engineering lends itself very well to doing that. And so that's another whole conversation. I think we could talk more about the unit economics another time. So I am foreshadowing another conversation around that. We didn't even touch AI and token
No, because
economics
we talked a lot about stuff. Future podcasts
next
will
time.
zoom in on some of those things. We've
Yeah,
already covered a lot today,
yeah,
which is good.
yeah.
I'll have
What
to
are the
think
basics?
cover too much. But thank you very, very much indeed for being on the podcast and showing us what the highest end of operational efficiency. So at the moment, you are the person who is the hands-on person representing the highest end of operational efficiency. So not code efficiency. I'm going to have a load of code efficiency experts on separately, but you are the operational efficiency high end. Don't everybody get um, uh, put off by the fact that actually you're really pushing the edge of this. Most enterprises, we're looking to you to find out where things are going, and what good will look like in maybe 5 years for the majority of enterprises. But it's really useful to talk to you, so we do know what good looks like, what we're all heading for. And all of
Thank
the
you.
tools, and as you say, all the tools that you use at Grafana are open source tools. They're available to everybody. Doesn't necessarily mean that you should use them immediately unless you're feeling very confident about your ability to do trial and error. But they're all open source tools. That's the other reason for talking to you here about this, rather than say talk to somebody at Google. A lot of the Google tools are still proprietary, internal. They're not proprietary, but they're internal tools. They haven't they're not open source, not available to everybody. But everything that you are doing, all this clever stuff that you're doing at Grafana, is open source. So, in theory, anybody could do it. In theory, don't do it. You
Yeah,
can do it. You can say don't do it without a lot of thought about your company culture before you go there.
yeah. Yeah,
But
there's a lot of organizational things that do need to happen before you can like replicate this whole pattern that I've just described. But everything is achievable, and I do sometimes see myself as like I'm clearing a path. I feel like
mm,
I'm clearing a path, and like showing others how to follow along. I definitely see that mental image quite often about where we're heading. And I'd love to we'll talk about token economics next
oh
time.
yeah, token ops. I really wanted to
Token
token
ops.
maxing versus token ops was the
Oh
subject
yeah.
of my of uh, Sarah Bergman and I did a podcast on environment variables that will come out imminently on token maxing versus token ops. Is token maxing evil, or is does it ever have a place versus token ops, which I will talk to you about at some point in the future.
Tokenomics. Let's add
Tokenomics.
tokenomics to the mix of terms.
Oh yeah, we can talk about token maxing, token ops, and tokenomics next time
Yeah,
you are
exactly.
on asynchronous and unreliable podcast. But for the moment, thank you very much, and you've given me a hell of a lot of stuff to edit to get this out today while it's still um, Earth Day
It's
somewhere in the
Earth
world.
Day. It's somewhere in the world. I'm sure it's still Earth Day. It's Earth Week, and it's Earth Day every day for us. And thank you so much, Anne, for everything that you do. And I'm so excited for Sarah's episode and all the other episodes in your podcast. And I'm so excited to come back as well and talk more about
Well,
tokenomics and everything
I
else.
look forward to it. So thank you, Nikki. Thank you to all our watchers and listeners, and hopefully I will see you again on a future episode of Asynchronous and Unreliable Podcast. Goodbye. Thank you very much for listening to Asynchronous and Unreliable Podcast. If you enjoyed the show and you want us to create more content, please do show your support by hitting the subscribe button below. It really does make a difference. Thank you very much.